Okay, so chapter 4, section 7 is using congruent triangles. And we're going to learn about something today that's going to make our lives a lot easier. It's just going to sound confusing at first, but then when I tell you just what it is in plain English, it's going to seem a lot easier. So here's how we're going to be able to prove that two segments or two angles are congruent. Let's say that we're looking at some triangles and we are trying to decide whether some angles are congruent. So let's say we've got two triangles. Here's one triangle, triangle A, B, C. And then there's also another triangle, triangle D, E, F. Here are some ways that we can prove that parts of them are congruent. First of all, if we can prove that two triangles that those parts are in are congruent. So let's say that I could prove that these two triangles are congruent. Let's say that I did this. I gave you this information right here. Okay, I started you off just like that. Are those two triangles congruent? Why? SAS. They are congruent because of SAS. That's step one. But let's say that my ultimate goal was to prove that AC and DF were congruent. That was my proof. Now that is not shown there. That's not shown. But we do know that these triangles are congruent. But what does congruent mean? Same size and same shape. So it's like pulling two toys off the shelf at a store that are exactly the same. It means everything about them is the same. And that's where we get into this next part. So once we have, you have to first prove that triangles are congruent. Prove that two triangles are congruent, and then you can do this next step. Then state that two parts are congruent using the reason corresponding parts of congruent triangles are congruent. Now, you don't need to remember all of this because we use this little acronym CPCTC. The corresponding parts of congruent triangles are congruent. And all that means is that if you've got two triangles that are congruent, then all of the parts that match up will also be congruent. Notice here that means that this angle down here would automatically be congruent to that one because they're already congruent, so all their parts match. This one down here would be congruent to this one, and this final side down there would be congruent. So we don't need to go through all those steps. Once you know that two triangles are congruent, we can just say that those other parts that we didn't talk about that match up, those are also congruent by CPCTC. Notice that every other letter is a C, in case you forget what this is. Every other letter is a C. CPCTC. The corresponding parts of congruent triangles are congruent. I don't expect you to remember that whole long thing, but at least remember CPCTC. That says if two triangles are congruent, then their parts are congruent as well. Okay, let's go through this proof here. It says that PR is this line right here. PR bisects angle QPS. This bisects angle QPS. What does that mean in plain English? What? Cuts what in half? So at the end of all this, what are the things that are congruent to each other? Like after, like not the whole thing, but just looking at this, what two things are congruent to each other? QPR and SPR. Those two things are congruent. That's what bisecting means because it bisected angle QPS. That's what we saw there. It bisected it, so this was congruent to that. And they told me that PQ is congruent to PS. Here is PQ. Here is PQ and PS. Anything else we know about this triangle? Yes, ma'am. Perfect. PR is congruent to PR. Are these triangles congruent?
Yes.
Why? Give me side angle side. That's exactly what I'm saying. Now, they did not ask me to prove, they did not say prove these triangles were congruent. They said prove that Q is congruent to S. So we already know by going through this proof. Let me just write this down real quick. And if you could write fairly quickly with me as well, I'm going to go and just put this as a proof here. I've got that PR bisects angle QPS and line PQ, line segment PQ is congruent to line segment PS. That was given. And then you guys told me that angle QPR is congruent to angle SPR because of what? Why were those two angles congruent to each other, Colette? definition of an angle bisector. Definition of angle bisector. And then, how did we get PR was congruent to PR? How did we get that? The reflexive property. And from there, we proved that triangle, I'm going to call it QPS. So look, QPS, I have to name this in the exact same way. QPR. I wanted to say QPR. I'm sorry. I was doing the top one first. QPR is congruent to, and I'm going to do it the exact same way, SPR. I'm following the exact same pattern. And why did we say those two triangles were congruent? SAS. So now we know that the two triangles are congruent. It should be an easy thing to say that angle Q is congruent to angle S, because that's just saying all we're doing now is we know they're exactly the same. So this angle up here must be the same as here. What did we just learn that we could do? What is that? What are those letters that we can use? CPCTC. The corresponding parts of congruent triangles are congruent. But don't ever, I'm going to tell you right now, you will always get CPCTC wrong if you do not prove the triangles are congruent first. You must, every single time, prove that these triangles are congruent. Always prove they're congruent, and then you can move forward. I'm going to pause, let people write, and then we're going to move on. Okie doke. Let's try another one. Notice that we are not trying to prove the triangles are congruent. We're trying to prove that a part of the triangle is congruent. So let's go from there. Let's start with what they told us. They've got PR bisects QPS. Well, we just saw something just like this. So PR bisects QPS. This is almost the exact same proof. Okay, so what do I get from that? That blue line down the middle bisected QPS. What do we get from that? In plain English, what happens? Splits what in half? The two angles. Okay, so which angles are now congruent to each other? QPR and SPR. Perfect. QPR, SPR are congruent to each other, just like we had last time. They also tell me... oh, that's all they've given me. Oh, okay. No, I see where this is going. Okay. It bisects QPS and QRS. It bisects QRS as well. So QRS is over here. This is not exactly the same. I was off there. And this one is being bisected as well. So angle QRP and angle SRP are also the same. What else do I know about these two triangles? What do you mean the middle? PR is congruent to PR because of? Are these two triangles congruent? For what reason? Angle, side angle. So now that we know that those two are the exact same triangle, they're exactly the same, everything about them is exactly the same, then it should make perfect sense that QR or RQ is congruent to RS over there. Because of what? The triangles are congruent, so their parts must be congruent. What was that? What did we just learn? CPCTC. Let's just put in a proof now. Statements, reasons. Okay, so we've got PR bisects angle QPS and angle QRS. That was given. We know that angle QPR is congruent to angle SPR because of the definition of angle bisector. But also, and I'm going to squeeze this onto one line here, we also found out that angle QRP, the one on the right, is congruent to SRP, the one on the right. That was still within the definition of an angle bisector. And then we got PR was congruent to PR, and that was the reflexive property. Now, again, just to show you that we can name this triangle anything we want, somebody give me 3 letters of the top triangle. Give me 3 letters. I don't care, just so I'm not like... PQR? I heard PQR. So I'm going to follow this pattern. PQR. R. That's the way I'm doing it. So my first one is going to be triangle PQR is congruent to, now I have to follow that same pattern here, PSR. Putting the letters in the wrong order could mean you get this line wrong. And we said that those triangles are congruent because of? ASA. So then why was it true that RQ was congruent to RS? We already know the triangles are congruent. CPCTC. The corresponding parts of congruent triangles are congruent. It means the parts of a triangle that match up, if these triangles are congruent, then their parts must be as well. I would expect if I bought two exact same toys at a store and I pulled them out, their shoes would look the same, their hands would look the same, their heads would look the same, everything would be the same. Yes, ma'am?
Okay, so when you say that it's ASA, you're talking about the angle with P and R?
Yeah, we're talking about here we've got A, S, A, and on the bottom, A, S, A. That's the ASA.
Okay, and why can it be side angle side as well?
Well, we don't have a side, this part, we don't get to use this part. That's what we're trying to prove.
Yeah, but on the other side, we know that because of the definition of bisector.
It's an angle bisector. So, it's only the angle that is split up, not the side being split up. So when we say it bisects an angle, it means the angle is split in two, not the sides are split in two.
Okay, and for the part where we say, then we need reflexive property to say that it's on the side.
All right. Okay, one more. Given that WX is congruent to YZ, I'm going to start marking these. WX is congruent to YZ, and ZW, here's ZW, is congruent to XY. We need to prove that WX, the one on the bottom, is parallel to ZY. Let's go through these steps there. Now, the CPCTC does not prove that two lines are parallel. It proves that parts are congruent. So just be careful with this. CPCTC is not about parallel. It's about congruent. So let's still go through this. First of all, this is what they gave us. Let's talk about what we know about these triangles here, just as plain human beings for a moment. Yes, ma'am? ZX is congruent to ZX. Anything else we know now? These two triangles are congruent because of side, side, side. Okay, now let's talk about some angles. We already know the triangles are congruent, so there's a lot more information we just opened up now. Yes, ma'am? Angle 1 is congruent to angle 2. Why? That's only if they're parallel. Yes, ma'am?
Definition of parallel triangles?
No, we don't know they're parallel yet.
Congruent.
We learned a different name today for what you're trying to say. What you are trying to say is the right idea. It's the wrong name. CPCTC. The corresponding parts. Notice here, and if you're not sure why 1 and 2, think about it. Look, here is the line that's got 3 marks on it, meeting up with the line that's got 1 mark on it. Up here is where the line with 1 mark meets up with the one that's got 3. So definitely those two angles are congruent. These two angles are congruent here because of CPCTC, and these here are congruent because of CPCTC. So we know that all those parts there are congruent because of CPCTC. So let's get down to the part where we got to that. And actually, I'm going to go back a little bit because what Colette told us about 2 and 1 is all we need to prove the lines are parallel. I didn't even need that other stuff there. So let's go through just the statements and reasons for a moment. First, we've got the givens. WX congruent to YZ. You shouldn't have to copy me on this part because you already know this part, what I'm writing. ZW is congruent to XY. That's given. Okay, then we went for the middle line, XZ congruent to XZ because of the reflexive property. That's the one down the middle. And then Colette told us that angle 2 is congruent to angle 1 because of CPCTC. CPCTC. Oh, yes. Oh, my goodness. Thank you. You're right. And actually, that was such a good catch because I just told you, literally, you can never say CPCTC until you say the triangles are congruent. And my own brain shut me off there. It's too early in the morning, not coffee o'clock yet. So we need to say first that triangle. Now, what do we want to call? I don't care whether we talk about the left triangle or the right triangle, but somebody give me 3 letters of one of those triangles. Colette. Okay, so she's going ZYX like that. So ZYX is congruent to, what is that going to be congruent to? XWZ. How did we know that? Because she started at the one that had this angle right there, so she had to start at that same angle here. XWZ. Triangle XWZ. And why were they congruent? SSS. Then we said angle 2 is congruent to angle 4 because of CPCTC. Oh, I said 4, right? I'm sorry. Goodness gracious. Now you know to get me coffee for Christmas. That's all I need. Just a cup of coffee. That's it. All right, angle 2 and angle 1 congruent CPCTC. Thank you. That's 2 mistakes in one day. I've used 2 years worth of mistakes right there in one shot. All right. Okay, so now that we know that, now we're trying to prove that the top line and the bottom line are parallel.
Because of converse alternate interior.
Beautiful. Because of the converse of alternate interior angles. So first we're going to say that WX, the bottom line, is parallel to ZY. It's very easy to write congruent. Be careful. Remember, we're trying to prove they're parallel because of the converse of alternate interior angles theorem.